All right, so your test on Monday is on 8.1, 8.2, and 8.3. So 8.1 is just kind of like general sequences. 8.2 is arithmetic sequences. That's when you add to get from one number to the next. And then 8.3 is geometric. And that's when you multiply to get from one number to the next. So there's two formulas that we have for arithmetic, and then two formulas for geometric, and we'll get to those when we get to 8.2 and 8.3. But let's start with 8.1. So write the first 6 terms of the sequence. So for 1 and 3, because we're just going to do the odd ones in this video, we just plug in 1 through 6. So we have 1 minus 3. My pencil works so well all day today until right now. So 1 minus 3, that would be -2. Then we do 2 minus 3, 3 minus 3, 4 minus 3, 5 minus 3, 6 minus 3. So 2 minus 3 is -1. Then we have 0, 1, 2, and 3. So our first 6 terms of the sequence are these. So all you have to do is plug in 1 through 6. We do the same thing for number 3. We have 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7, not 7, just the first 6. So this would be 1, 8, 27, 64, 125, and 6 cubed is 216, I think. So these would be our first 6 terms of our sequence for number 3. Any questions on 1 or 3? Those are not too bad. So just plug in 1 through 6 for n. All right. In the next section, we describe the pattern and write the next term and write a rule for the nth term of the sequence. So these are not arithmetic and not geometric, so we have to figure out our own rule. So we have a sub n is equal to, remember, when it's a fraction, take it one step at a time. So let's just look at our numerators. What do you think our rule is going to be in our numerator each time our numerator is 5? 5. It doesn't change. If it was n, let's say we said n was on top. That means when we plug 1 in for n, we would have 1 on our numerator. If we plug 2 in for n, we'd have 2. So that's when it changes. When it's just a constant number, it's just going to be that number. So that's our numerator. Let's look at our denominator. What are we doing to get from 2 to 4? Multiplying by 2. What about from 4 to 8? Multiplying by 2 and multiplying by 2. So what do you think our denominator is going to be?
2 to the power of n.
Awesome. 2 to the power of n. So you can always check your work by plugging in 1, 2, 3, and 4. Whatever term you're working with, plug in that number and it'll make sense in your rule here. What is the next number in our sequence going to be?
5 over 32.
Awesome. 5 over 32. So real quick, I'm just going to do it on the side. A little like helpful guide, I guess we could say. When going from one number to the next, if we were adding, let's say we're adding 2 to get from one number to the next. Add 2, add 2, add 2. Our rule would be 2 times n. If we were multiplying, let's say multiplying by 3 to get from one number to the next. Times 3, times 3, times 3. Our rule would be 3 to the power of n. So that's if you're adding and if you're multiplying, another common one from the section for 8.1, so 8.1 is kind of like a Mod Podge of different sequences we could have. If we have perfect squares, so we could have 1, 4, 9, 16. So we see that these are all perfect squares. We're not adding or subtracting or multiplying to get to anything to the next. These are perfect squares. So our rule would be n squared because they're perfect squares. If we had perfect cubes, we'd have 1, 1, 8, 27, 4 cubed would be 64, so this would be n cubed. So just keep an eye out for these common ones, especially these two, because they're not going to be arithmetic or geometric, but we can still come up with a rule for them. All right, let's look at 13. So to come up with our rule, we take it one step at a time. Let's look at our top. What are we doing to get from 2 to 4? Multiply by 2. So what's our rule going to be in our numerator? 2 to the power of n, because we said we're multiplying by 2, so it looks like this. So it would be 2 to the power of n. What about for our denominator? What are we doing to get from 3 to 9? Multiplying by 3, and we are multiplying by 3, and multiplying by 3. So what's our denominator going to be? 3 to the power of n. Perfect. Any questions on these two? All right, let's look at 21. So we're doing the same thing for these, except they are a series, which means we are adding each number together. So we just have to put our little summation squiggly line there. So we always start with 1. And instead of n's, we use i's. But the same idea, we're just going to look at the tops first. And then we look at the bottoms. So what are we doing to get from one number to the next? Adding 1. So how do we write adding 1 as a rule? 1n or just n. Perfect. So that's our top. What about for the bottoms? What are we doing to get from 7 to 8? Adding 1. And what about 8 to 9? Adding 1 and adding 1. So what do you think our rule for the bottom is going to be? So we can't just put n, because if we said n, then that means we're starting with 1.
Plus 6. N plus 6.
Awesome. So it'd have to be n plus 6. Perfect. Because that way when we plug 1 in, we have 1 on the top and 7 on the bottom.
Or is it I plus 6?
Oh yeah, it's I. You are right.
Oh, okay. Would I get it wrong if I put n?
No, you would not get it wrong if you put n instead of I.
No points off or anything?
No. It's the same thing, just a different variable. Some of the examples in here, they use like k.
Yeah.
So it's the same thing.
Okay.
What do you think our number on the top is going to be? Awesome. The infinity, because we have this little dot, 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 which means our series goes on forever. So on the top of our sigma, we put an infinity sign. All right.
Is equal to 1/7 on the bottom of the sigma?
I is equal to 1. Yeah, that's what you should start with.
1 or 1/7?
How is it plus 6?
Because we want this on the bottom when we plug in 1 for I. So 1, and then 1 plus 6 would be 1 over 7, which is what we get here for our first term. For our second term, we plug in 2, which would be 2 over 2 plus 6, which is 2 over 8. So that gives us this one. So you just kind of have to see. So we know that since we're adding 1, we start with n, but since this starts with 7, we need n, when we plug in 1, to be 7. So it has to be plus 6, because that would give us that 7 when we plug in 1. Does that make sense?
Yeah.
Okay.
But I is 1, not 1, 7.
I is 1. Because we start with 1, and then keep plugging in the next number. Because you always start with 1 here. So it'll always start with I is equal to 1. Alright, so for 23 and 25, we need to find the sum. So when you have a small number on top, like 5, 6, 7, something not too big, it's easiest just to plug in 1 through whatever number you have here. So here we're going to plug in 1, 2, 3, 4, and 5. Because we're just plugging in 1 through 5. So we plug in 1 times 6, 6 times 2, 6 times 3, 6 times 4, and 6 times 5. So 1 times 6 is 6, 2 times 6 is 12, 3 times 6 is 18, 6 times 4 is 24, and 6 times 5 is 30. And then summation, this squiggly line, means that we add them. So we just have to add up all of these numbers. What do you get when you add them?
90.
Awesome. 90. So our answer here is 90. On your test, I need to see all of this work. I have to see your work. You can't just write 90.
Okay. Instead of like plugging it in.
Alright, 25. So what number should we start plugging in here? 2. So we're going to start with 2, then 3, then 4, then 5, then 6, then 7. So we have 3 times 2 plus 2, 3 times 3 plus 2, 3 times 4 plus 2, 3 times 5 plus 2, and 3 times 6 plus 2, and 3 times 7 plus 2. 3 times 2 plus 2 is what? 8. 3 times 3 plus 2? 11. What about the next one? 14. And then? 17. And then? 20. This should be 2. So 20. Yeah, then 23. What do we get when we add them all together? What was that?
93.
93. Everybody agrees? Yeah. 93. Any questions from this section? So just remember, the little summation means we add. So 8.2, this is our arithmetic sequence, which means we add to get from one number to the next. Our two formulas are a sub n is equal to a sub 1 plus n minus 1 times d. And then we also have our sum of an arithmetic sequence, which is n times a sub 1 plus a sub n over 2. So a sub 1 is our first term. D is our common difference. N is our number of terms. A sub n is our last term. So in 1 and 3, we have to tell whether the sequence is arithmetic and explain your reasoning. So what are we adding to get from 100 to 50?
You're not adding it, you're dividing it.
Well, in order for it to be arithmetic, we have to add or subtract.
Well, minus negative 50.
So we're subtracting 50. Are we subtracting 50 to get from 50 to 25?
No.
No. So is this arithmetic?
No.
No. But is it geometric?
Yeah.
Yeah, it would be geometric because we're dividing by 2. But it doesn't ask us that. It just asks if it's arithmetic. But that's a great point. Anytime we have fractions, we want our denominators to be the same because that'll help us identify what we're doing for each term. So if I want my denominator here to be 6, what do I have to do to my second number? Multiply by 2. So I have 2 over 6 as my second term. What about for the third term? What do I have to do here to get my denominator to be 6? Multiply by 3 over 3. And then the fourth term? Multiply by 2 over 2. So you get 4 over 6. So if you see, we go from 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6. So are we adding the same thing to get from one term to the next?
Yeah.
What are we adding? 1/6. So is this arithmetic?
Yeah.
Yes. Alright, let's look at 5a. So the first term is 12 and each term is 7 less than the previous term. So we use our formula a sub n is equal to a sub 1 plus n minus 1 times d. So to find our general rule, we just have to plug in our a sub 1, which is our first term, and d, which is our common difference. So what's our first term? 12 plus n minus 1. What's our common difference?
Negative 7.
-7. Perfect, because it says each one is 7 less than, so that makes it a -7. And then we just want to simplify this a bit, so what should I do to simplify? Distribute the -7, so it would be -7n plus 7. And then what else do I have to do? Add 12 plus 7, so -7n plus 19. That is our rule. So anytime it asks for your rule, it's always going to be your little formula, and it's always going to have the n in it, because that means we can plug in any number for n to find that term. So that is our rule. So that was A. Let's do 7 and 9. So write a rule for the nth term of the sequence, then find a sub 20. So we need our formula again. A sub n is equal to a sub 1 plus n minus 1 times d. So we need to find our first term, a sub 1, and our common difference. What are we doing to get from one term to the next?
Adding by 10.
For 7.
Dividing by 3.
Arithmetic. So we're adding or subtracting. Look at this. What are we doing to get from -4/3 to 0? We're adding 4/3. So we're adding 4/3 here and adding 4/3 here. So what's our common difference? 4/3. What's our first term? -4. So let's plug that into our formula. We have a sub n is equal to a sub 1, which is -4, plus n minus 1 times d, which is 4/3. Let's simplify a bit. So a sub n is equal to -4. We have to distribute, so 4/3 n minus 4/3. Can I do anything else? I can combine -4 and -4/3. But I need my -4 to have a denominator of 3 in order to combine these. So I'm going to multiply the top and the bottom by 3. So this becomes -12/3. So -12 minus 4 is -16/3. So my formula here is a sub n is equal to 4/3 n minus 16/3.
How did you know this one was arithmetic?
We know that it's arithmetic because it's in the arithmetic section, but it's also that we're adding to get from one term to the next. We're not multiplying.
On like the test, will it say like arithmetic?
All right. So next thing we had to do for this one, for number 7, is to find a sub 20. So what are we going to plug in for n? 20. So 4/3 times 20 minus 16/3. So 4 times 20 is 80/3 minus 16/3. 80 minus 16, 64. So 64/3 is our 20th term. The fractions kind of make it a little bit more work, but not really more difficult. You just got to make sure you're taking your time with what you're doing. You all know how to add and multiply with fractions, so it's not too bad. All right, let's look at number 9. What are we doing to get from one term to the next? Subtracting 0.7. So what is our a sub 1? 2.2. And what's our common difference? -0.7. So we plug that into our formula. We have a sub n is equal to a sub 1 plus n minus 1 times d. So we can distribute our d. 2.2 plus, or minus, actually, this would be a minus now, 0.7n plus 0.7. So a sub n is equal to -0.7n. And then what is 2.2 plus 0.7? 2.9. And then we have to find a sub 20. So -0.7 times 20 plus 2.9. You guys can use your calculator for the test, so don't be scared when you have decimals. You just put in your calculator. So -0.7 times 20 plus 2.9. And that would be, what'd you guys get for this one? -11.1. And so let's look at number 1. We have to tell whether the sequence is geometric. In geometric, we have two new formulas. So that is a sub n is equal to a sub 1 times r to the power of n minus 1. That's our general rule. And then we also have our sum, which is s sub n is equal to a sub 1 times 1 minus r to the power of n over 1 minus r. So the only difference here is we have this new r, which is just our common ratio. Anybody remember how we find the common ratio?
Yeah, pretty sure you divide the second term by the first.
Awesome. Second term divided by the first term. So in number 1, tell whether the sequence is geometric, explain your reasoning. What are we multiplying by to get from 3 to 6?
2.
Multiplying by 2. Are we multiplying to get are we multiplying by 2 to get from 6 to 18?
No.
Nope. So is this
Nope.
not geometric? Nope. Number 3. What are we multiplying to get from 0.7 to 3.5? Remember, you can always take your second term, so 3.5, divided by the first term, 0.7. That gives us 5. So we're multiplying by 5. Are we multiplying by 5 here? Yes, you guys can use your calculator, so you don't even have to do the math. Just put it in your calculator. Yes. We're multiplying by 5 each time. So is this geometric?
Yes.
Yes. Any questions on this part? All right, number 5. Write a rule for the geometric sequence with the given description. We'll do A again. So to write our rule, it is A sub n is equal to A sub 1 times r to the power of n minus 1. So what is our first term?
Negative 12.
Negative 12. What's our common ratio?
7.
7. And then we just have n minus 1. That is our rule. Any questions on this one? All right, let's jump to number 7. We have to write a rule for the nth term of the sequence and find A sub 7. So what are we multiplying to get from 80 to 20?
You're dividing by 4.
But what are we multiplying by?
1/4.
Awesome. We're multiplying by 1/4. And you can always check that by taking the second term and dividing by the first. And that'll give you 1/4. So that's our r. So just remember, we are dividing by 4. That is true. But to plug into our formula, you need what you're multiplying by, so it's 1/4.
Okay.
So just be careful with that. So A sub n is equal to, what's our first term? What's A sub 1?
40.
80. It's right here. Always the first one on the list. So 80 times 1/4 to the power of n minus 1. So this is our rule. And then it asks us to find A sub 7. So what are we going to plug in for n? 7. Make sure you know how to put this in your calculator. So we have 1/4 to the power of 6. And then we multiply that times 80. So that gives us A sub 7 is equal to, I got 0.01953.
So you don't have to leave it as a fraction, you can do it as a decimal?
Yes, unless it is multiple choice, you might see it as a fraction, which I'll do that also. So in case it's multiple choice, and your only answer choices are fractions. If we had 1 divided by 4, we would need to see what 4 to the 6th power is, because that would, 1 to the 6th power is still just 1, and 4 to the 6th power would be 4,096. And then we multiply that times 80. So this would give us 80 over 4,096. And then we could simplify. So 4 goes into both of these. 20 times and 1,024. I think 4 goes into both of them again. Yeah. So 5 times and 256 times. So that would be our fraction. So I would accept this as the answer, totally fine. But just in case, if it's multiple choice and all your answers are just fractions, you would have to leave it as a fraction like this.
And you would do that by putting 1 to the power of 6 and then 4 to the power of 6?
So yeah, this is 1/4 to the power of 6 is like saying 1 to the power of 6 over 4 to the power of 6.
And then you multiply
Yeah. And then we just multiply it by 80. Good questions. Any other questions on that one? All right, let's look at number 9. What are we multiplying to get from one term to the second term? Remember, you can always take your second term and divide it by the first. We're multiplying by -2. So our r is -2. What's our a sub 1? 1.2, the first term. So a sub n is equal to a sub 1, which is 1.2, times r to the power of n minus 1. This is our rule. It asks us for the 7th term, so what are we plugging in for n? 7. So 1.2 times -2 to the power of 7 minus 1. So 1.2 to the power of -2. 1.2 times -2 to the power of 6. -2 to the power of 6 is 64. So 1.2 times 64. Which is, what'd you guys get? 76.8, hopefully. So that's our a sub 7.
When you put in your calculator, can you just put the parentheses, or is that like?
Try putting the parentheses with it, and then try not putting the parentheses and see if you get the same. If it's a negative, I would always just put the parentheses just so it knows that your negative is what's being to that exponent also. Okay, we only have like 2 minutes left, so I'll do 15 through 17 in the video, and you guys will just have to watch it tomorrow. Alright, so let's do 15. So we have to find the sum. This is when those formulas come in handy, the ones that are s sub n. So s sub n is equal to, when it's arithmetic, so when it looks like this and you just have an n that's not in the exponent, this is arithmetic. So that's when n times a sub 1 plus a sub n over 2 is how we find the sum. So we have to use this. This is arithmetic. This is our arithmetic sum formula. So our sum of our 9 terms here, so we could say s sub 9 is going to be equal to, our n is 9 because we have 9 numbers from 1 to 9. A sub 1 is our first term, and a sub n is our last term. So it's always the first plus the last divided by 2. So to find a sub 1, we just plug in 1 into n. So 3 times 1 plus 5. 3 times 1 plus 5 is 8. Next, we plug in 9, so our last term, into n. So we have 3 times 9 plus 5. 3 times 9 is 27. 27 plus 5 is 32. So 8 plus 32 divided by 2. So this would be our sum of our 9 terms is equal to 9 times 40 over 2, which would be 20, so 9 times 20, and 9 times 20 is 180. So for questions like these, you could always plug in 1, 2, 3, 4, 5, 6, 7, 8, 9, and add them all up. But it would just take you way too long, especially if you had multiple questions like these on the test. So use the formula. Also, if you had like an n as 20, it would take you forever. So use the formula. Whenever it's an arithmetic, so if it looks like this, you're going to use the formula. All right, let's look at 17 also. So this, we have our variable in the exponent, so this is a geometric sum. So we're going to use our geometric sum formula, which is S sub n is equal to a sub 1 times 1 minus r to the power of n over 1 minus r. So S sub n is equal to our first term. So if we plug 1 in for I, that would be negative 4 times 1/2 to the power of 1 plus 3. So negative 4 times 1/2 to the power of 4. We can put that in our calculator. So we get a sub 1 is 0.25. So 0.25 times 1 minus r is whatever has that exponent on it. So 1/2. N is the number of terms. So we're going from 1 to 12. So we have 12 numbers here. Divided by 1 minus 1/2. So 1/2 to the power of 12. 1 minus that number would be 0.99975. We want to keep it in the calculator so we get the most exact answer as possible. So then I'm going to divide that by 1 minus 1/2, which is just 1/2. So divide it by 0.5. And I get 1.9995, and then I'm going to multiply that by 0.25. So that gives me my sum as 0.4998.